Hello everyone, my name is Viktorija. I am a mobile test engineer. Today marks 2 years that I am working at Wix, and probably as many of you here, I do not particularly like mobile manual testing or any manual testing at all. So I have spent last year working with detox automation library. It all started from the very first QA E2E test, and it was a really interesting journey to where we are now, having hundreds of tests running in CI as a threshold for our quality, for our application to reach our users. To start from the top, mobile applications are increasingly popular every year. More and more users are doing their daily activities that used to be done on computers or even in more primitive ways, meaning that we rely so much on our applications means that they need to be reliable. And especially for our users, as they have their businesses and most of their income comes through mobile application. So this is where QAs come in picture, doing manual and automation testing. For Wix and our React Native mobile application, Appium was not the right tool to avoid manual testing. This is when developers thought of creating a new tool, which is called Detox. So, in this talk's agenda, you can see that we will start at really high level to understand what is React Native and automation testing, and then we will dig deeper into detox overview and configurations, objects, and test building material, followed by a demo of how tests look like on your simulator or emulator. So, React Native. It's a framework created by Facebook. Its predecessor is React, which is web development framework. React Native compiles to applications both for iOS and Android. It's based on JavaScript and is very similar to React. There is a popular saying in development community that you can learn once and use React Native everywhere. That's how I want to write my test too, that you might think. And that's exactly what you can do. The test that you write can run both on iOS and Android. So to understand better React Native, you need to understand these 4 terms described here. So first of all, native is something that is built for specific platform. These might be alerts in the screen or something like that. Then we have JavaScript, which is shared code between platforms, and it usually holds all the business logic of the app. Then we have components, which are UI elements provided by React Native or built on demand. And some of these you might know if you have ever had any experience with HTML. These elements are like view, text, list, or whatever else. And then we have bridge, which is asynchronous, and it's used by React Native to communicate between native and JavaScript side, and vice versa, from JavaScript to native side. In this example here, you can see how the bridge works, and this image also includes all the 4 elements that I described in previous slides. So first of all, user makes some kind of an action, and that action goes into the native side, where native button handler sends directions over the bridge to JavaScript side, where handler logic is being performed. After this logic is performed, handler response is formed plus UI rendering instructions, and this information is sent over the bridge back to the native side where native views are being built, and then we can see the outcome of our initial action on the screen. It's really important to mention that bridge is black box and developers do not control it. You can think of it as a messaging system. You input some kind of a message and you send it out, and you do not care much of its implementation because you just want recipient to receive that message. And all the messages go in queue to be handled by JavaScript. Of course, like all the other frameworks, React Native also has issues. So one of the main issues is the framework's maturity, because it's fairly new framework and together with community is still being developed. and also its documentation is still being developed. And fun fact, in 2018, React Native GitHub repo was the second most contributed to repo in GitHub. Also, there will probably be no platforms parity anytime in the future because iOS and Android are always going to have their differences, and we can compare even such a simple thing as navigation, where on iOS you would swipe screen from one side to the other to navigate from to previous screen, and on Android you usually have dedicated native button for that. Also, when testing, you need to take into account both native and JavaScript side. For developers, it's really important what actions are being done over the bridge, what is being sent over it, because every action is costly both resource-wise and time-wise. And all of this above creates a quite complex environment that makes a React Native app. So right now, I'm going to talk about automation testing in high level just to provide you background on what is coming up next. So you have probably seen this pyramid before or a variation to it, and it basically portrays a mindset that bottom levels of pyramid should have more automation cases than the top levels. So unit tests should have most tests, then mock E2E tests should have a bit less tests, and so on until the top, where we have production E2E tests that should have the least amount of tests. That is because unit tests and mock E2E tests are more stable than production tests. I must agree that this pyramid can seem a bit too simplistic, but it can provide you a good view on when you probably should stop writing those production E2E tests and maybe choose another level of tests to write. And now, for any of you who has less automation experience, I will briefly describe every level of this pyramid. So let's start with unit tests. Unit tests are pure code oriented, therefore they are easy to write for developers and easy to maintain. They greatly improve code quality. In some cases, developers even use this kind of approach where they first write automation tests for a specific functionality and then only they start writing the code for some kind of a logic, and then that logic is being already tested by the test, and then you can verify that everything works. And it also allows you to find bugs easily at the very earliest possible stage before going to QAs or production or whatever. But one of the main cons is that it's pure code oriented because it only checks functionality from the code side. It does not represent actual user flows. Therefore, it does not reflect app quality. And then you would like to step into another level, which is mock E2E test, because they are closer to code and production, and they tend to be stable because you are not communicating with real server. You do not care about network because all of that is being mocked. They are easy to maintain because they are not flaky, of what I mentioned before. But then you have cons. First of all, mock E2E tests are hard to set up and write, and that would be mostly the case for QA engineers who do not have much experience in coding, because you need to mock all the requests that are going out and coming in. And it still gives you limited confidence because, as we all know, sometimes bugs can also happen in the server side. Of that, you would just be simply blind. So that's why you want to create production E2E, and we as QAs probably would want to have hundreds and hundreds of them to cover everything that is possible, because they mock real user experience. They are easy to set up and easy to write, and they give you high confidence that your application is working. It means that if that case is passing in your production E2E, you can be 80–90% sure, which is a lot, that this flow would not be failing for your users. But cons include the fact that production E2Es are slow because you are waiting for real server responses to come back, and that can take from milliseconds to seconds. They are hard to maintain and less cost effective. And these 2 points are mostly caused by test flakiness. So, flakiness is one of the most annoying aspects of E2E tests because tests sometimes fail without even anything changing. It's almost a scare word for QAs because if your tests are flaky, this means that your test is unreliable and it cannot replace manual labor. Flakiness happens because tests are non-deterministic. Every time test executes, things could take order in a slightly different way, although you don't see it. Consider a scenario where multiple network requests are being done at the same time. What would be the order of execution? Well, it depends on which request completes first, and this is an external concern that is being impacted by network speed, by server, and so on. Usual way to deal with such flakiness is adding various sleep commands throughout your tests, but it's a bad practice riddled with a lot of strange and mystery numbers that could often change and your app would still be flaky because the simulator that you run your tests on can be faster or slower, and that does not depend on you. Detox is designed in such a way that you do not need to use sleep at all in your test code. So let's start Detox overview now. Well, first of all, Wix tried using Appium, really tried using Appium for 2 years and 8 months together with React Native, but it was understood that a reasonable portion of time went to nurturing system and monitoring CI and fixing what is not really failing instead of creating features. Frequent failures in CI meant that tests are not reliable at all. To solve this, sleeps were added to tests, but that slowed the test greatly, and that is why Detox Gray Box end-to-end testing and automation library for mobile apps was created. To elaborate definition of Detox, we also need to mention that Detox is cross-platform. As I mentioned before, it runs tests both on iOS and Android. Detox is made to work for CI, whether it's TeamCity, Travis, or whatever else platform that you are using. Detox is test runner independent. By default, test runner is Mocha, but we have recently switched to Jest with no difficulties, and I will talk about this a bit more later. And Detox tests are automatically synchronized because Detox can track all the asynchronous operations inside your app. So if gray box is not entirely sure what that means, we can compare it to black box. Black box testing would go over the view hierarchy of your application and search for an element. If it's not found, it would execute a sleep, wait for some defined time to pass, and then search for that element in view hierarchy again. Gray box testing is different because it has access to internal memory. So gray box tests track the app main operation queue to see whether there are any pending network requests, whether main thread is idle, if all animations on screen have completed or not. Test execute on main thread to make sure that nothing is changing in UI while tests are being executed. But there is downside to that. Because of gray box, there is a different compilation and running process, so this is a bit more difficult for developers. But it was worth sacrificing this for them, and it's totally worth for us because it lets us to run our tests really easily. So this is how gray boxing happens. You can see here that there is a check checking whether app is idle or not, and this and then it goes into loop. If app is not idle, then it waits for a few milliseconds only and loops again until the app is idle. And because this is done every few milliseconds, so basically it happens as fast as possible, and just when it's able, it advances to the next step to execute further tests. So when detox tests are running, you actually have two parts running at the same time. So the first part is mobile app itself running on simulator or multiple simulators, because detox supports multi-threaded test runs. And the second part is the test suite that is running on Node.js outside of the application, and it communicates with the app over WebSocket. Let's dig deeper into detox technical details, starting with configuration now. So here you can see what can be defined for configurations. Configurations themselves are defined in package.json file, and you can define as many of them as you want, because you might want a large number of different devices running your tests. So first of all, you need to define binary path that is a relative path from package.json to the application that you are testing. Then you need to define the application, the simulator type, whether it's iOS simulator or Android emulator. Then you need to define the device name. For example, for iOS, that would be the same as it would be one of the devices that are specified in Xcode simulator list. And then you can define, if you want, an optional build command that would run before tests. So this is an example how this would look like. So we have configuration of a specific name, then we define binary path, build command, type, and name, which is iPhone 7 Plus. So this specific device would be selected in that case. You can also define server and test runner configurations. For server, usual test case is to define whether you want to use mock or real server that is provided, and then you can define a test runner. Mocha is the test runner by default, but you can define a different one. And then after you define configuration, you can just simply attach the flag of configuration to your test and run your test with this single line. So next we will talk about detox object. Is globally available in every test file, and it has 4 main methods. So first one is detox init, detox.beforeEach, detox afterEach, and cleanup. Let's talk about each of them. So detox init reads configuration that is defined in package.json. It starts a server that is also defined there. Then it loads detox expectation library to be used and runs a simulator. Detox.beforeEach is called at the start of every test, and this is where detox tells that it needs to start logging network, it needs to start video recording, taking screenshots, and else. This is not the only usage of beforeEach. We do not limit you in that. And it's important that in this step, if you would have any skipped tests, it would be attaching pending label in this very test for that case. And then in afterEach, where you must return a failed or passed value for every test that was marked as pending because you wanted to skip it, no value would be returned at all. Only for one test you set failed or passed value. And then detox cleanup phase starts, where server is shut down after all the afterEaches have finished and your tests end. Let's talk about device object, which is also globally available in every test file. It enables control over the attached device, and it has a lot of different functions for you to mock user experience as closely as possible. So here you can see the list of those different device functions. In purple, I have highlighted some functions that I personally use the most. So we have launch app, which is pretty descriptive from its name, send to home, which would put application to the background from which you can then rise your application. You have an install app, you have enable and disable synchronization that allows you to turn on and off synchronization mechanism, and it's pretty important and useful, and I will be talking about them in a few slides. And then we have device.get platform, which is useful when you are working with both iOS and Android and you want to know which exact case should be applying in terms you need some kind of a hack, or you have differences in the UI depending on platform. Device launch app function also has different parameters that you can set. Again, in purple I have highlighted the ones that I use most. So we have new instance, whether app should be killed before opening or not. Then we have set runtime permissions. That is a really great parameter if you want to avoid any possible native alerts. For example, when you run application for the first time, you would get an alert that would you like to allow notifications. You do not want to see that, as it could cause flakiness, and it also includes different parameters as permissions for photo library, permissions for camera, calendar, etc. Then we have launch from fresh installation and launch from URL. This allows us to run our app whether it was triggered by some kind of an external call or a link. So this is how launch app function could look like. So new instance true, URL defined, language and locale also can be selected, and permissions to calendar set to yes. So we can view detox and device object as the foundation of our tests. And now we will talk about test building material, which is actions, matchers, and expectations. So what are they for? Matchers are for specifying UI elements that are existing in the view hierarchy. Then actions are how we are behaving with those elements and emulating user behavior, and expectations are used to validate that action that we performed on a matcher executed on the right way and we got the outcome we desired. So there are these kinds of matchers that you could use, and of course probably all of us would use by ID because it's the most specific that we can use, but we can also search for elements by text, by label, by type, and by trace. By type would be more like a class name in JavaScript, but in Detox it's called by type. And for more uniqueness, we can also add a different level of matchers, which would be by ancestor to go back in the view hierarchy of the element, with descendant to go in front of the element in the view hierarchy, and add another matcher at the same level by appending it with AND. So finding matchers for element are not that hard. As you can see in this example, we have, first of all, class name defined at the top, which would be matcher by type. Then we have description, which would be matcher by text. And then we have identifier, which of course would be matcher by ID. So for this selected element here that is highlighted using Xcode, we would probably use matcher by ID as this is the most unique that we can do. Sometimes it's not that easy, and in this artificial, not quite realistic example, I just wanted to show you how can you use multiple level matchers. So let's say that in this screen we have a lot of toggles that are using the same ID, which is just simply toggle with no indexing, with nothing unique. Then you would say, let's go to the ancestor and see what the card all that is behind this element has, what kind of ID it has. And then you find out that, oh no, it's also not unique ID. So what you do next, you might try to go to the descendant of the card element to verify by text. And how that would look like. So we define that we are waiting for element by ID, which is not unique toggle, which has ancestor by ID notification list item, which is then again not unique. And if you're not going to developers by now saying, hey, what's up with this? You can go to the descendant element and verify it by text, allow notifications, and expect this element to exist. But of course, it's not really good practice from development side. So next are the actions that we can do, and they can basically be divided into 3 different groups. So first group is tapping, of which example you can see here. So we have tap, long press, multi-tap, and tap at point. Tap at point is some kind of a hacky function that shouldn't be used in perfect scenario, because depending on different devices, it would change element location and you would not be able to use it. You would probably not find the element to tap on. Then we have typing, type text, replace text, clear text. Replace text can be used to save those extra seconds from typing everything into your keyboard. And then we have scroll and swipe. It might seem the same from user side when you are scrolling and swiping, but actually scrolling works only on scroll type elements, where with swipe you can use it on any element you can see in view hierarchy. So it's also a hack when you don't have you have multiple matchers of scroll type. And then we have expectations, and I think they are really descriptive from their name. There's not much to explain here. The only difference that would be good to understand, that to be visible is different from to exist, because with to exist you can verify element that is not actually on the screen. Maybe it's somewhere at the bottom but you don't want to scroll all the way to it. Then you can verify it with to exist and make your test go faster. Let's talk about manual synchronization now. So Earl Grey for iOS and Espresso for Android are frameworks that provide synchronization mechanism used by Detox. They wait automatically for app to be idle by tracking main dispatch queue, main operation queue, network, animations, and so on. But what happens if application does not become idle? So we can disable synchronization in that case. Popular example would be, let's say we have some kind of an animation that keeps rendering on the screen and is keeping the app main thread busy. You can see button here that is moving up and down. Or let's say you are uploading a file or a photo, and while it's loading you still want to perform actions on your screen. So in that case, you can disable synchronization before entering such screen that doesn't become idle, or before performing an action that keeps app busy. And then you can work with any of the elements in the app. But you must remember to enable synchronization back again when you are done working with non-idle situation, because disabling synchronization means that you are working on quite unrealistic expectations that real user would not experience. But if you forget to re-enable synchronization, it also resets with every new app instance. But there is one catch. Sometimes you need to use wait for, because if you disable synchronization, you enter some kind of a screen. It's not rendered at the same second. It can take some time for elements to appear, for something to load. So you add a wait for that is waiting for a specific element that you describe to match the expectation that you define, also with a timeout of milliseconds. This is not at all similar to sleep, because this is being wait for is checking for element again for every few milliseconds, and as soon as possible it proceeds to the next step. You must use this together with an expectation, because wait for by itself does not return pass or failed value for that step. So to verify that the element was actually appearing after the before the timeout exceeded, you add expectation. So right now, I will show you a quick demo of how test looks inside a simulator, so that you can see that it's actually really similar to what user would do. So the scenario of this demo is that user signs up into the app as a new user, then joins a site with invite code, which is predefined in this case. Then it verifies after joining that site would be visible in Home tab. So let's just wait for it a little to catch up with us. So here it enters the invite code. Site is joined. And after that, we verify it's visible in Home tab. Then we want to hide that site from Home tab to verify hide functionality. We verify that it's not visible, and then we make it visible once again. It really looks easy, doesn't it? So, I really hope that this talk has sparked your interest into detox, and if you have not tried it before, you can try it yourself, because this is an open source project, and you can find it via GitHub link over here. And that's it. Thank you very much for listening.